All right, welcome. Today we are going to take a look at multiplying fractions using models and then also multiplying fractions using the algorithm or the procedure. So we want to remember that multiplying fractions is often represented as repeating or repeated groups or as a part of the whole. And we really want to focus on that word of, because a lot of times when we see that word of, it's going to indicate multiplication for this unit and then moving forward. The example we're going to use first is going to be 2/3 times 6. So when we think about this, we can either think of it as 2/3 of 6 or 6 groups of 2/3, because as we know, multiplication is commutative, so we can switch the order. So looking at it as 6 groups of 2/3, or you could take 2/3 of the value of 6. As we're looking through this, what I'm going to do is I'm going to make 6 groups. So I'm going to make 6 circles. And each of those circles is going to be split into thirds, since thirds is our denominator. And that tells us how many pieces we have. And then I'm just going to go ahead and shade in 2/3 of each of my circles. Now, when I look at 6 groups of 2/3, I can see that taking 6 times 2/3, I didn't change my denominator because I didn't cut my fractions any differently. They stayed as groups of 3 to make a whole. And in the end, I have 2 pieces per circle, so I end up with a total of 12 pieces. And my answer ends up being an improper fraction of 12/3, but I can simplify that because 12 divided by 3 is 4. So my final value would be 4. Another way we can look at the same problem is using something called the bar model. The thing that I like about the bar model in particular is it does have uses in other areas. It can also sometimes be called a tape diagram. So when we look at a bar model, what's going to happen is instead of having 6 distinct groups, we're going to have one bar that represents our entire whole. So in this case, our bar is going to represent 6. Since my denominator is 3, I'm going to take my whole and I'm going to cut it into 3 pieces. So I'm going to take that 6 and divide it by 3, which makes each of these pieces worth 2. And now I just think about, well, what is the part that I'm taking? I'm taking 2/3. So I'm taking 2 of these pieces. Now what are those 2 pieces worth together? They're worth 4. So in the end here, our answer, just like we did before, is still a value of 4. So that's 2 different ways to multiply with a model using a whole number and a fraction. What we're going to look at next is what happens when I'm multiplying a fraction by a fraction. And when I do that, I often want to think about using shading. So looking at this, I'm going to kind of think about this as 2/3 of 1/2. So I'm going to take my pan or my model and I'm going to cut it first in half, and then I'm going to shade it half of it. So that kind of almost represents that like part of the pan of brownies that we have left, but that's that half. And then I'm going to now take 2/3 of that, so I'm going to split into thirds, cutting it the other way, kind of like we're cutting pieces of brownies. Now, when I do my shading, I'm going to shade 2/3. So when we do 2/3 of 1/2 or 2/3 times 1/2, our answer, as we can see for our denominator, how many pieces is the whole pan cut into? Well, it was cut into 6 pieces. And then what we're looking for is that part of the part. So where is that overlap? So in this case, the overlap are these pieces that were shaded twice. So we can only count the pieces that were originally there. So in this case, there are 2 pieces, so our answer would be 2/6, which we could also simplify because these are both even numbers, and that would give me a final answer, or a better answer, of 1/3. So we want to remember that the double shaded part represents the answer in our problem. So this all kind of just helps explain and lead to our algorithm that we can use, right? So as we're kind of thinking through this, we're thinking about how when we did these in class, how they ended up leading us to notice that there was a pattern happening. And what ends up happening is that when we multiply fractions, we can just multiply across. And that's why when we were multiplying a fraction times a whole number, it's because all whole numbers really have a denominator or can be put over the value of 1. So I take that 6 and I put it over 1, and then I just multiply across. So 2 times 6 is 12, and then 3 times 1 is 3. So we end up with 12 over 3. But like we said before, we can divide 12 by 3. You end up with an answer of 4. And then when we multiply a fraction by a fraction, really we're going to just multiply both of these parts. So we're going to multiply the numerator and multiply the denominator. In this case, we would do 2 times 1. It's going to give us a value of 2. And then 3 times 2 gives us a value of 6. Since these are both even, I can divide them by 2. And in the end, we end up with a final answer of 1/3.